Okay, I'll be discussing on how to find the centroid of a plane area when the region is a composite, is coming from a composite figure. Now, for composite figures are actually figures which can be divided into two or more basic geometric figures. To find their centroids, the Varignon's theorem is applied. So here is the formula. No? It is coming from Varignon's theorem. So actually, this is the summation of the product of area and its moment arm. No? So the distance from the centroid to an axis of reference. No? So area total with its own, with the distance of the centroid from the axis of reference. Actually, this behaves under a Varignon's theorem. Then we have also the other equation when it comes to finding the Bardway. So where is the total area of composite figures? A1, A sub 2, A sub n are the area of individual figures. No? So x is the distance parallel to the x-axis from the center of gravity or the centroid of the area to the reference axis. So y is the distance parallel to y-axis from the centroid of the area to the reference axis or the center of gravity. Okay? Now, steps in locating the centroid. You divide the figure into common geometric figures. You choose a reference axis, determine the area of each figure as being divided. No? So, determine the centroid of each figure. Identify the distance from the centroid of its divided areas to the reference axis. Then you can apply the Varignon's theorem. Now, suppose you are given a problem like this. No? So, here is the figure. No? Now, if you notice, our figure given is actually symmetrical, no? Or it has a line of symmetry which can be found where? Okay, so if you draw a line here, so the meaning, ang atong left portion and the right portion are actually the same when we consider an axis of symmetry right here. Okay? So, one of its coordinates, so there is an advantage of having a line of symmetry because we can easily determine the location of the centroid wherein the centroid can be found within the axis of symmetry. Okay, now, as solution, okay, I am dividing my area into parts or my region into parts, no? I mark here E1. My E1 is actually the area for the entire figure which is rectangular. The ito is the one which is the hollow portion. This is not actually covered by your seeded part. No? So this is not part of the seeded portion. No? So A2. Now, to get the total area, so from my figure, notation used for E1 and E2, so my area, net area, is equal to the difference of E1 and A2. Then I can determine my E1. My E1 is a product of pila? 60 mm and 50 mm. So 3,000 square millimeter. My E2, which is to be deducted, is 30. This is 30 times 20. That is 600. So the area for the seeded part is equal to 2,400 square millimeter. Now take note of the area equation you have because this equation you have will also be used in the moment equation to determine the centroid. Now, if I'm after for the centroid, then I can have, okay, I can consider the line of symmetry. The line of symmetry is here. And there is an advantage of knowing the line of symmetry because I can determine the location of my centroid right at this axis. Okay, but only I do not know exactly from the base is its location. But I know that from y-axis horizontally, now this is already the location of my centroid. And what's the value of x right here? So that is why my centroid has a coordinate which is known already, which is half of 60. With that is half of 60, so that is equal to 30 mm. However, my Bardway or the distance from the x-axis, no, is not known yet. No? So this is Bardway and unknown. So this is to be solved. No? So only one of the coordinates will be solved. Now, if ever there is no axis of reference given, so I put my reference axis x right here and my y-axis being here. Okay? Actually, you can choose any point, no, or any location of your reference axis. But in your exam, I'm going to put the reference axis so that our answer will be made uniform, no? Okay, ngayon. So, to solve for the barred y, so barred y is a distance from the x-axis. So, which means if there is a mass that is concentrated here, then there must be a rotation of the body about the x-axis. No? So, you can take moment about the x-axis. The moment about the x-axis defines your distance, barred y. So, E barred y, then the components of your area, E1, so it is paired with the moment arm, y1 and the y2. Where is your y1? If this is E1, this is the entire figure which is rectangular, my y1 is the distance vertically to the centroid of the entire rectangle. So if I have 50, so my y1 is 25. Okay? So it is 3,000 for the value of A times 25. Minus A2, that is 600 times pila. This is 30. Half of that is 15. So you can have the barred y. That's the centroid. So I'm not going to waste time solving for my barred x because of symmetry, barred x is already known as 30 mm. And the barred y is assigned that is 27.5. So this is now the answer for this kind of problem. Okay. When you are asked to locate the centroid and your figure is like this, so we are now dealing with another geometric figure. This is a semicircle. We can maybe break this into rectangle and a triangle, no? Or if you choose, you may extend this dire and include this part which is not part of the given region. Okay, so my way of finding the area, okay, so yun. So to find my area, so I consider the whole rectangle. Actually, kini akong giabot diri. I'm extending my line here, my boundaries here. So akong giapil ang y labot. Okay, so we have area of the rectangle, this one. Then I subtracted the area of the semicircle. Okay, and since I'm including a triangular part here, so I can also subtract the area of the triangle. Area of the rectangle is pila man 5 times 12. Okay, that is 60. For semicircle, area of a circle is pi r squared. What is the radius here? If the diameter is equal to 6, the radius is equal to 3. So it is half of the pi r squared. So that is 9 over 2 or 4.5 pi. Okay? So, triangle, 1/2 base. What's the base? 4. The height is 5. So 1/2. Okay? 4 times 5. So that is 10 square millimeter. So combining them, I have 35.862 approximately. Okay? So that is the area of the shaded part. Okay, then I can go with the moment about y to solve for the barred x. This one. The moment about y, so my area equation ganina is paired with a moment arm of barred x. So this can be paired with a moment arm or distances to the axis of reference y. Na? Direct. Okay. Area of the rectangle is 60. From y, this is pila to 12. If that is 12, so half of that is the location of my centroid. So that would be 6. So that is 60 times 6. No? This is the distance to the reference axis from the centroid of my entire rectangle. No? Now, semicircle. This is the area of the semicircle multiplied with, now semicircle has a line of symmetry. So I can determine the distance of the centroid from y to the axis of symmetry, which is pila? 3. So you multiply by 3. Area of the triangle is 10. But take note, if you consider this one, the centroid of the triangle, if you recall, I'm already giving you the copy now ahead. So the centroid of the triangle is 1/3 from the side and 1/3 from the base. Diba? So sa ato pa, 1/3 of this, if this is 4, so that is 4/3. But my distance, the centroid of this will be based from my reference. That is why there is 12 minus 4/3 because that distance is the distance coming from here paingon there. 12 minus 4 over 3. Okay, combining them, I arrive at the value, then I have to divide with the area, then there is a result which is 5.881 meters. No? Now, taking moment, for taking moment with respect to x, by the way, there is another geometric figure, which is this one. Actually, the location of the centroid is from the base, so this is not used yet, and we know in our copy that the barred y is equal to 4r, if this is my barred y, na, barred y distance, this one. So, gikan sa yung base, buti pasabot, okay, this is not the barred y, because the barred y is gikan diri, padong dito. Okay, from this figure itself, no, that is equal to 4r over 3 pi. So, the radius of this is equal to 3, di ba? Being equal to 6 is the diameter, so 4 times 3 over 3, so 4 over pi, na? So, as the result, that distance is from the base, okay, along the axis of symmetry. So, the centroid is here. Okay? Now, taking moment about x, a barred y. So, if my centroid is here, this is my barred y. A barred y. Rectangle, what is your YR? Half of 5. Yan, kay vertically man ka. No? My centroid is there. No? So, that is half of 5, 2.5. Minus area of the semicircle. Then, we have 5 minus 4 over pi. Actually, we know this is 5 then. So, if I'm going to take the distance from my reference, which is x, so that is 5 minus this value. Manang doon na kay 5 minus 4 over pi. Minus the area of the triangle. Then, the centroid of my triangle is, if I'm going to use the vertical distance, no? So, it can be 1/3 gikan dire nga side, no? That's 1/3 at that side, okay? So, if this is 5, so 1/3 of 5, so 5 over 3. But, taking the distance of my centroid of my triangle from my reference, which is x, so, that would be 5 minus 5/3. So, calculating, I arrive at the value of the barred y, then I can have the centroid, which is, okay, so you can assign the coordinates of your point. Okay, so, if you are given problem like this, so this is intended for you to practice, no? Okay, then the answer is provided. Actually, I take this from the book of Engineer Prito, no? Okay, so, the area for this is this one, and the answer can be calculated as this. Okay, one of the answer, the 105, is not necessarily be calculated because if you observe, this figure has a line of symmetry. So, I know this distance vertically. That is pila, 65 plus 40. This is a semicircle with a radius of 105. So, this is 105. So, mo na 105 imong barred y. So, what you need to solve is only the barred x from y. No? So, gikan diha, asa dapit imuhang location sa imuhang centroid. And if solved, you will arrive with this as the value. So, with that, pwede na ka mag-practice and I hope it is fully understood. Okay? So, thank you and thank you for watching and have a good day.